Okay, so this is an introduction to really the basis of calculus. And our graphs aren't normally, like, we would never have a real world graph where it's just about x's and y's, but we could have a graph where, let's say this is hours and this is miles, and this just represents our trip. And let's say after, for instance, don't take notes on this, just follow along on this. Let's say maybe down the road after 4 hours we're 200 miles down the road. So this would be the point 4, 200. And somehow or another, we, GPS, we were tracked along there, and that just represented our progress from point A, let's say, to point B. And we could make lots of conclusions based on this. We could say, well, if in 4 hours I traveled 200 miles, I averaged 50 miles per hour. Was I traveling at 50 miles per hour the whole time? Nope. I was traveling faster here than I was there. In fact, right along here you could argue we were in a traffic jam, or if it went flat for a while, maybe we stopped to fill up the gas tank or something like that. So we're going pretty slow here. If, for instance, it would have done this, then we had to turn back for a while. Are you with me? But what we might want to know, if we could have the graph, you could see maybe we want to know, hey, how fast was I going right then, at that moment, at that instant, how fast was I going? Now, it'd be really easy to know how fast we're going here, because we're going to measure that in miles per hour, y's divided by x's, change of y divided by, it's just the slope, right? That's how fast we're going, would be the slope from here to here. I want to know the slope at this instant, but here's the challenge. For slope, here's what we know about it. We have to take a y value, try this again, a y value minus a y value, and divide it by an x value, 2 and 1, an x value minus an x value. Right? We have to have two different points. The problem is, it appears like momentarily after this point, I'm going faster, and prior to it, I'm going slower. And I could pick a point really close to it. For instance, let's say we actually, on our trip, right here, we were traveling along something that modeled plain old y equals x squared for simplicity. And let's say this 2, 4, maybe we were just walking. It represents after 2 hours we were 4 miles away. But then we started walking faster, and we were walking slower to begin with. I want to know how fast we're walking at that instant. But I need 2 points. So I could, for instance, choose a point close to it, 2.1, and 2.1 squared is 4.41. And I could say, well, let's find the slope between those. Will that be exactly how fast I'm going at 2? It's going to be a little bit quicker, isn't it? Because I'm kind of finding the slope from here to here. But I could do that, and I could say, well, it's 4.41 minus 4 on 2.1 minus 2. I get 0.41 on 0.1, and that is, if I multiply top and by 10, that's 4.1. And we could say, well, we're going about 4.1 miles per hour, but I believe a little bit less than that. Is that clear? Because by the time we include this point, we're actually going faster. I'd say, what's my speed at 2.1? Well, it's probably a little bit more than 4.1 miles per hour. What if I need to know exactly? Okay. Let's keep considering y equals x squared. So on this curve, any point on there I could call x squared. That's how we get our ordered pairs. I'm going to choose a point close to it, And I'm going to say, so let's say we're just right here. So this just represents, to get from here to here, I went over x, and then the height is x squared. I'm going to choose a point that's just over a little bit more. I'm going to say this distance is h. Why h? Why not? It's a good variable. It's a good letter. So this point right here, to get to it, I've gone over x plus h. How high is it there? Well, I got to put x plus h into this function. It's x plus h squared high. Is that okay? Now, ideally, I want h, we understand, need to point here because they won't see that on the video. Ideally, I want h to be really, really, really tiny. And in a perfect world, h would just be 0. Okay, so what's my slope now? My slope is the y, x plus h squared minus the y, x squared on x, which is x plus h minus this x value, x. Is that crystal clear that I just found the slope between these 2 points, even though they're not regular numbers? That's when you nod or shake your head no or raise your hand. Y minus y over x minus x. Now, remember, ideally we wish it was this point twice. Ideally it was just this point and this point. But take a look. If I put 0 in, if I put 0 in for h and I have the same point, I get x squared minus x squared, 0 on x's cancel if h is, I get 0 on 0. And 0 on 0 is in large part the whole genesis of calculus, is how do we handle 0 on 0? How do we handle how fast something's growing at an instant when it's not growing at the same rate all the time? We're not always going 50 miles an hour. How do we handle 0 on 0? Well, 0 divided by anything is 0, but we can't divide by 0, and we can kind of figure out what's going on. 3 divided by 0, well, let's say I had 3 divided by 0.000001. That's like 300,000. 3 divided by 0 wants to be approaching infinity. So, I don't know, 0 on 0, it's 0. Oh, no, it's infinity. No, it's 17. How in the world can you say that? Well, if I make this 17 on 1 and I cross multiply, I get 0 equals 0. So 0 on 0 must be 17. Like, it can't be anything. It must be 0. It could be everything. 0 on 0 is a big troublemaker for us. All right, let's continue here. FOIL. X squared plus 2xh plus h squared minus x squared. On the x's cancel, I get h. Simplify. Oh, the x squareds cancel. 2xh plus h squared on h. I wish h could be 0. H can't be 0. I'd get 0. Can't do that. H can't be 0. I'd get 0 plus 0 on 0. 0 on 0, it's troublemaker, but I can cancel h. And I get 2x plus h. And now if h is 0, I get 2x. Function x squared. Its slope formula, we're going to call it for right now, is 2x. Slope formula for plain old x squared is 2x. So I come back to, let's go back to this graph right here. We've got 0, 0. Along the way, we've got 1, 1. We've got, not really to scale, 2, 4. We've got 3, 9. Hands, if you can tell me what the slope is, what the slope is at the point 2, 4. What's that instantaneous tangent line slope? How fast are we going at 2, 4? If we know the slope formula is 2 times x. Yep. is 4. It's 2 times x. We're going 4 miles per hour. What is our slope at 3.9? And everybody said on 3, 1, 2, 3. 6. It's 2 times 3, 6. How fast are we going at 0, 0? 0. Back here there's a point. -4, 16. What's the slope? 1, 2, 3. -8. Is that okay? That's our slope formula. All right. I want you to try to make a prediction, share it with somebody next to you, what you think the slope formula for 3x squared is. I'm going to give you about 30 seconds. Try to make a prediction. What you think the slope formula for that is, show it to somebody next to you. If you're watching this on video, you can fast forward if you've got a prediction. Okay, we got them? How many of you are, like, if you're sitting by somebody, you're in agreement with it? All right, let's see what we got here. We're going to play scientist a lot, but right now we're going to go back to math. So on 3x squared, any point can be called x 3x squared. Slide to the right a little bit, x plus h. We get 3 times the x plus h squared. So our slope would become 3 times quantity x plus h squared minus 3x squared, all on x plus h minus x, which we quickly find out is, once again, h. So let's see, that is 3 times x squared plus 2xh plus h squared, FOILed, minus 3x squared on h. That is 3x squared plus 6xh plus h squared, 3h squared, excuse me, plus 3h squared minus 3x squared on h. The x squares, the 3x squareds cancel. I get 6xh plus 3h squared on h. And if I choose 0 for h, I got problems. But I can cancel h, and I get 6x plus 3h. And now if I let h equal 0, if this is 0, I just get 6x. Hands if you had a prediction of 6x. About half of you, great. How about a prediction for x squared minus 4x? Might be less on this, but I think we're going to get some people to get their prediction right. I'll give you 30 seconds. Okay, we got them? That was more than 30 seconds. How many of you are in agreement with somebody next to you? All right, we'll see if you're right. We'll find out. So, I put in x, I square it and subtract 4x, there's our standard point. Then I slide to the right, x plus h, I get x plus h squared minus 4 times x plus h. So our slope is, I'm going to go brackets here, x plus h squared minus 4 times x plus h. And you can just watch this. I think most of you are just watching this. And then that has to, from that I have to subtract all of x squared minus 4x. That's y minus y. It's messy. All on x minus x, but that's x plus h minus x. That's just h. Guess algebraically what I want to have happen down the road. I think somebody said it. I want to cancel that h down the road. Somebody say that? I think I heard it. I want to cancel that h down the road because we can't divide by 0, right? Man, can this possibly still work? Let's see. X plus h squared. X squared plus 2xh plus h squared, distribute negative 4, minus 4x, minus 4h. Distribute the negative, minus x squared plus 4x. All on h. Anything good happen? X squared's gone. 4x is gone. Every single term that's left has an h in it. I can cancel h. And I get 2x, the h cancels, plus one of the h's cancel, h, minus 4, and now h can be 0. And if h is 0, I get 2x minus 4. Hands if you had 2x minus 4. Yeah, numbers went down just a little bit, but I bet they go up on this next one. Okay. Study that one a little bit. See if you can make sense out of this one. Make your predictions. Anybody in agreement? If you're agreeing with somebody by you, check with somebody not by you. Okay, a little messier function, not one that we haven't dealt with plenty of times. I put in x. I square it, multiply it by 5, multiply it by 2, add 3, add those together. So if I put in x plus h goes here, behind the 2, and the 3's alone. And I've got to find my slope. So my slope is going to be y. 5 times x plus h squared plus 2 times x plus h plus 3 minus all of y. 5x squared plus 2x plus 3. There's the y's minus the y's. X's minus x's. Oh, that's easy. That's h. Okay. Well, let's go. 5 times x squared plus 2xh plus h squared plus, let's see, 2x plus 2h plus 3 minus 5x squared minus 2x minus 3 on h, or 5x squared plus 10xh, not trying to cancel anything yet, plus 5h squared plus 2x plus 2h plus 3 minus 5x squared minus 2x minus 3 on h. Man, I hope everything that's not an h cancels. Does this 5x squared cancel? Yep. Wow, are you going to be lost? All right. 5h squared, this doesn't cancel. Does this 2x cancel? Yes. 3's cancel? Yes. Anything else combine? No. Can we reduce by h? Yes. And I get 10x plus 5h plus 2. Now I can put 0 in for h, and I get 10x plus 2. Hands if you had 10x plus 2.
Nice. She did not have that.
She didn't have
She did not have one of my three options.
All right. 10x plus 2. Let's take a look. If you're baffled how somebody could have gotten that. We know the slope formula for x squared is 2x. What's the slope formula for negative 4x? Y equals negative 4x. What's the slope formula for that? Well, what's the slope of y equals negative 4x? It's always negative 4, right? The slope of negative 4x is always negative 4. So it's just the slope of this and the slope of that. Right? So if we know 3x squared becomes 6x, I don't think it's too much of a stretch to see what might be happening here and get 5x squared becomes 10x. What's the slope of the line 2x plus 3? 2. 2. Or what's the slope of 2x? 2. What's the slope of the line y equals 3? 0. Hands if you think you can do probably any quadratic I might give you in this form. So for instance, if I give you negative 3x squared minus 6x minus 2. See if we can do this in unison. The very, very first thing I'm going to write. 1, 2, 3. Negative 6x. The next thing I'm going to write, 1, 2, 3. Minus 6. That's it. That's our slope formula. Okay? I would like you to find the slope formula of this function. F of x is ax squared plus bx plus c. And we'd write slope formula typically. We'll use this little prime figure. We say f prime is. That's how we get slope formula. Jot that one down, the slope of this. I'd like to think we're going to be well over 50% here. We have a gigantic light bulb moment here in a minute. Won't even see it coming. Although Tess did last hour, she saw it coming. It's incredible. How about slope formula of ax squared in 1, 2, 3? 2ax. Awesome. Awesome. How about, what's the slope of this line, bx plus c? Plus b. Hands if you had 2ax plus b. Let the record show. That's about 80%. That's good. Okay, let's talk parabolas just for a minute. I got this parabola right here. You can answer one of three ways, positive, negative, or 0. Tell me what the slope is here. 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 Can I find it 0 anywhere else? So the slope of a parabola is only 0 once, right? And this is any old parabola, right? What if I set its slope equal to 0 and solve for x? Any light bulbs just pop on? X would equal, subtract b, divide by 2a. What happens, what do we know about the vertex when the slope is 0? Or the parabola? We know it's the vertex, right? It's the vertex of the parabola. So the vertex of the parabola is located at negative b on 2a. You ever hear that before? Talked about that before? When you learned Algebra 1, you should have learned this. This should have been part of the curriculum. That's a very, very easy way to get the location of the vertex. If I want the location of the vertex of 2x squared minus 4x plus 3, I'm going to say, well, the slope formula is 4x minus 4. When's that 0? When x equals 1. The vertex is at x equals 1. No more, nothing more to memorize now. I can find slope formulas. All right, our numbers are going to go down on this. F, slope formula. Predictions for x cubed. I'm going to give you about 20 seconds just to try to come up with a prediction for x cubed. You might already have it right now. I'm going to say I'll be surprised if 50% get this right. And you may be really confident that you have it right now. I wouldn't get it right if I had to do it sitting where you are. Okay. Lock in your predictions. Here we go. Somewhere this curve starts heading like this. On there we've got x cubed, and near it we've got x plus h. We've got x plus h cubed. So our slope formula would be y minus y, x plus h cubed minus x cubed, all on x plus h minus x, all on h. You guys ever worked with Pascal's triangle before? And binomial theorem, or how you can expand these things? You're going to just trust me on this one then. X plus h cubed is 1x cubed plus 3 x squared h's plus 3 x but h squareds and plus h cubed. That's the expansion of this. Minus x cubed on h, yay, cancels. H, yay, reduces 3x squared plus 3xh plus h squared. And now h can be 0, gone. Hands if you had 3x squared. About a third of the class. Hands if you had 3x. Yeah, I think I would have been in that camp right there. It's 3x squared. How about 4x cubed on the count of 3? 1, 2, 3. 12x squared. It's three times as tall, right? 3 times as tall. 12x squared. How about negative 3x cubed minus 2x squared plus 4x minus 6? Slope formula of this first term. 1, 2, 3. X squared. Second term. 1, 2, 3. 1, 2, 3. Plus 4. Very good. So if I wanted to know my rate of speed, let's say this was miles per hour and this is my location, if I wanted to know how fast I'm going at time 3, I can just put 3 in here and get our slope. Understand how slope formula works for us? Okay. Sneaky. I will tell you, it is not square root of 1. And you're going to say, well, how in the world? We haven't even seen anything about square roots. All we've seen is x raised to powers. Oh. We know how to handle it when x is raised to a power. Oh, I think I can do this. If only this was written as x raised to some power. If only I could represent this as x to the 1/2. Even that, there may be some little trickery here, but don't we, I mean, you tell me, what do you suppose the slope formula of x to the 7th is? 1, 2, 3. It is 7x to the 6th. Notice, x squared was 2x to the 1st. X cubed was 3x to the 2nd. We have at least some reason to believe this might be the case. So, not equal to, just the slope formula of, what would we do here? Who wants to give me this one? Got a confident pair back there. Anybody else want to take a shot at? Anybody want to take a shot at this? Yep. 1/2. It is not 1/2 x.
2x?
It is not 2x.
Yeah.
1 over 2x.
It is not 1 over 2x, but I like your thinking. Where'd this 6 come from? Where'd this 2 come from? What's happening here? Yep.
1/2 x to the negative first.
1/2 x to the what?
Negative first.
No.
Half.
1/2 x to the negative 1/2. Reduce it by 1. We could write that as 1 on 2 to the square, or 2 times square root of x. How about this? X to the negative 4th. I shouldn't even have given it to you that way first. I should have given it to you this way and said 1 on x to the 4th. And then I would have told you, oh, by the way, it's not 1 on 4x cubed. It's not 1 on 4x cubed. X to the negative 4th. Exactly the same rule that got us to here.
Negative 4x to the negative third, fifth.
Negative 4x to the negative 5th. Okay. That, the rule we've kind of specialized in here is referred to power rule, and tomorrow we're gonna talk about how we're gonna apply that on the test. But if you can, you got the very beginning portion of the very first question, first part of the first question of the test, you got it made now. If you could do this, if you could find the slope formula of that. Hands if you feel like, yeah, I can give you the slope formula of that. 9x squared plus 10x minus 3. Okay. If you're not 100% on board with that, that's okay. But you need to be. You need to be by tomorrow, by the end of the day tomorrow. Okay.